Okay, with these log equations, we're going to have to condense first before we do anything else. So with this first one, on the left side of the equal sign, I have two logs being added together. So I'm going to take what's on the inside of the logs and I'm going to multiply them. So I have x times x minus 3. X times x minus 3, I just distribute my x, so I get log base 2 of x squared minus 3x. So now I'm going to rewrite this in exponential form. So I have 2 squared equals x squared minus 3x. 2 squared is just 4. And now I have a quadratic to solve. I need to move the 4 over, so I'm going to subtract it over. And then I need to figure out what multiplies to negative 4 and adds to negative 3. So that would be negative 4 and a positive 1. Those multiply to negative 4 and they add to negative 3. So now to solve, I get 4 and negative 1. The last thing I need to do is make sure that I don't have any negative numbers inside of my log. So I'm checking my solutions. If I look back up to my original problem, inside my logs I have x and x minus 3. Well, 4 would work for both of those. But negative 1 would make both of them negative. So my final answer is just x equals 4. Okay, number 22, again I have to condense, so I have log base 3 of 3x times 2x plus 1 equals 2. Distribute my 3x. And now I'm going to change this to exponential form. So 3 squared equals 6x squared plus 3x. 3 squared is just 9. And subtract over my 9. Oh, minus. Okay, I noticed that all of my coefficients can be divided by 3, so I'm going to divide a 3 on both sides. And now I have this quadratic to solve. So since I have a 2 out front, since this is not just an x squared quadratic, I'm going to have to use my star factoring. So in the top middle goes a times c, so 2 times negative 3. In the bottom goes 1, because it's 1x for b. Top left and right, I'm going to put ax and ax. And then my factors go on the bottom left and bottom right. So I'm going to figure out what multiplies to negative 6 and adds to 1. That would be positive 3 and negative 2. Okay, after I found my factors, I'm going to simplify them if possible. The only one I can simplify is 2 over negative 2. So dividing both of those by 2, I get x over negative 1 for that factor. So my factors are 2x plus 3, that's what I get from the left side, and x minus 1, which is what I get from the right side. Okay, so now I need to solve each of these. X minus 1 is pretty easy to solve. I just change the sign of 1. I get x equals 1. But 2x plus 3, you might want to set equal to 0 and solve by hand just to make sure you get the right answer. So subtract over the 3 and then divide by 2. So I get x equals negative 3 over 2 and 1. Again, my 1 came from this factor. So now I need to figure out if I have any extraneous solutions. So looking back up to the original problem, I have log of 3x and 2x plus 1. Well, if I were to plug 1 into both of those, I would still have a positive number on the inside. So 1 is good. But if I plug in negative 3 over 2, I would have a negative number. So my only answer here is x equals 1. Okay, for this last one, same idea. I have a ln natural log going on. So ln of, it's going to be x times x plus 4, because I have an addition going on between my two logs. Distribute your x. Now I need to write this in exponential form. Remember that ln is just base e, so I'm going to have e to the third power equals x squared plus 4x. If you put e to the third in your calculator, you get approximately 20, so we're going to go with 20 on this problem. Subtract the 20 over, and now we have a quadratic to factor. Okay, with this factor, with this quadratic, I'm going to check to see if I can see what multiplies to negative 20 and adds to 4. Well, if you think about it for a minute, there are no factors that do this, so I'm going to have to use my quadratic formula. So, quadratic formula, if you forgot it, you can Google it really quick. But I'm just going to have negative b, so negative 4, plus or minus the square root of b squared minus 4 times a times c, all over 2 times a. So once I put this in my calculator, simplify it, I get x equals 2.9. Oops, I put 2.2. 2.9 and negative 6.9. Now note that negative 6.9 would make the inside of my log negative, so that's not going to be one of my solutions. My only solution here is x equals 2.9. Okay, and another word problem here. We have 50 grams of radium stored in a container. The amount R of radium, represented after t years, can be modeled by this exponential equation. After how many years will only 20 grams of radium be present? So we're trying to solve for how many years. That variable is t. So we have 20 grams of radium that I'm plugging in for my R equals 50 e to the negative 0.00034 t. Oh, not 43. Okay, so in order to solve this exponential equation, the first thing I have to do is get rid of this number out front. So I'm going to divide both sides by 50. Okay, and now I'm going to change it into log form. So with log form, I'm going to use ln. So I have ln of 0.4 equals negative 0.00043t. I can divide both sides by this decimal. And I get t equals 2,131 years. Okay, for the last part of this problem, it says 75 grams of radium are stored in different containers. The amount R of radium present after t years can be modeled by this new equation. What will take more years or fewer? Will it take more years or fewer years for 20 grams of radium in this container to be present compared to your answer in part A? So now again we're solving for years and we want to know when there's going to be 20 grams left. So plug 20 in for R and we're going to compare our answer to part A. Divide both sides by 75. Change it to log form, so I have ln of 20 over 75 equals negative 0.00043t. And then divide both sides by your negative decimal there. We get t equals 3,074 years. So this one is actually more.